So here we are at the end of first quarter, and as unique and strange as it may have been, it was also fairly successful. The way we got through the material and the success we had with it, technology, whether you were home or in school, I would consider it an overall success. So at the end of the quarter, we're going to go back and take a peek at everything that we did. We looked at angles, parallel lines, transversals, triangles, isosceles triangles, mid-segment theorem, Pythagorean theorem. Then we got into rigid motions, talked a little bit about orientation, definitions of rigid motions, composite rigid motions, meaning we do 2 or more steps, and congruent statements. So let's go back and see if we can use our notes, use our materials, our resources, our old videos, and to help you out with the first quarter grade, we will count this as the Edpuzzle grade and add it to your first quarter. Good luck. So there'll be a little hint with each one here. The first one, solve for x and y. Yes, there's vertical angles here, but they're in different variables, so you can't do anything with those two yet. But you can do something with these two. Those add up to a certain number, and then once you solve for x, you could figure out what x is and then solve for y. Number 2 appears to be 2 parallel lines, and we'll go ahead and make those parallel, cut by a transversal here. Now 3x plus 8 is this angle, 4x minus 3 is that angle. So not only do we want you to solve for x, but I also want you to solve for angle GFH. Remember, you start at G, you turn at F, and you head toward H. So once you've found x, plug that in to find the measure of GFH. First though, what's the relationship between this and this? Remember, it's open notes, and it's going to help your grade for the first quarter, so go back and look it up if you're not sure. Okay, so here we have a bow tie situation with 2 triangles. If you notice though, this triangle is scalene, at least it appears to be, and this one is definitely isosceles because of those 2 markings. So I would definitely try to figure out this angle first, which will lead you to that angle, which will then lead you to that angle. What is x? Number 4. To add some things to this picture to make it official, that is a midpoint and that is a midpoint. And it could either tell you that that's a midpoint in words off to the side, or it could make markings like that showing that those 2 segments are the same length, which means that would have to be in the middle. And I could do the same thing on the other side. If those 2 are the same, then that has to be in the middle. So then once you have midpoints, you have a mid-segment. So look up your mid-segment notes and find the relationship between that and that. Solve for x, and then find the length of MN after you've solved for x. Now, once we realized not everybody was super comfortable with the Pythagorean theorem, we went and did a little bit of a review on it. So I know you have a lot of resources for Pythagorean theorem, so go back and look in your notes, find the Pythagorean theorem. Notice that this is the hypotenuse, so that would be side C, and you're looking for the missing side. So using the Pythagorean theorem, solve for this missing side. So number 6 has 2 parts. We look at triangle NFL, and it wants you to perform that rigid motion. So the first question you ask yourself is, where is x equals 3? Where is that line? Is it here? Does it look like the x-axis and goes through 3? Or does it cut through the x-axis at 3? Reflect over x equals 3. I'm going to ask you where n prime ends up. And question B, after you performed this rigid motion, was orientation preserved? Go back up and look orientation up in your notes and see what happens when you do that with orientation. Was it preserved? And explain. Number 7, you're taking the triangle VHS and you're going to perform this rigid motion. Now you can do that several ways. You could put patty paper over it and use the trick where you are rotating it around the origin. 180 degrees is totally facing the other way. Or you could look up your rules for 180, or you could turn your paper. We did a lesson a week or two ago about 3 different methods to perform this rigid motion. So once you have that, I'm going to ask you where V prime is. So if you've rotated correctly, where is V prime? Question B, is your new triangle a rigid motion? Why or why not? Number 8, here's another rigid motion, which I just answered that for you. It's a translation of -2, 5. So it's translating -2, 5. I'm going to ask you where Y prime ends up after that. Question B, again, is it a rigid motion, and why or why not? Number 9 is a composition, and it's written in function notation, so you have to ask yourself, which one do I do first? Do I read normal left to right, or with a composition function notation, do I go the opposite direction, right to left? You'll want to remember that from previous lessons. Once you've done that, and you performed both rigid motions in the correct order, I'm going to ask you where A prime ends up. And if A prime is in the right spot, then I'm sure your other points are in the right spot. And the last question. Triangle BAM and triangle B prime, A prime, M prime are both graphed, the pre-image and the image, and we're asking how did that happen? What rigid motion mapped the blue one onto the purple one? And then, the final part, 10B, write the congruent statement below. What is congruent to what? Which one is correct?